Hello, Year 7s. We're going to do another experiment. And I have my trusty assistant here, Professor Bones, being all safe, wearing his face mask. Okay, before I actually start this experiment, I'm hoping that you've read the material from last week, and in that material that you copied down in your notebook, there was some examples of different types of magnets. I've got some here for you. This is a horseshoe magnet. You've already seen the bar magnets. So there are bar magnets. You can see the north written on them, so the opposite end is south. And here, this is a ring magnet. So there's 3 different types of magnets. Okay, so the experiment we're going to do, you'll need your textbook. And if you go to assignment and tasks on Zuno, there'll be a task that says, practical report, what does a magnet attract? This sheet will be attached to that. Now, if you need hard copies, they will be in the foyer. I need you to print out this sheet so that you can conduct the experiment. And really, really important, have a look in the table. You'll need to do predictions, which I've spelt wrong. Whoops! I put an A in there. Okay, so what we'll do is you need to get your textbook out and you need to turn to page 268. Once you turn to page 268, you'll find this experiment. What does a magnet attract? I want you to read through that and I'll help. It says, place a magnet close to a range of materials to find out which one's attracted to it. Record your observations in the table below. You've already got that table. I've done it up for you over here. Okay. Now we can't have attract or repel because the objects will not repel as they're not a magnet. Only a magnet to magnet may repel. These materials, they're either going to attract, so they'll stick to the magnet, or they won't. Second dot point, test as many of the following items as possible. You can look in your results table for all the items that we've got. And we're not going to do the third dot point, okay? And then you'll have to do the discussion questions. All right, let's get into the experiment. Now remember, before each one, so you'll need to pause, you have to predict. We could predict them all at once if you like, and you can just use ticks and crosses if you like. If you think it will attract, so if you think the pencil will attract, tick. If you think the plastic straw won't attract, cross it, okay? And then when I'm doing the experiment, you'll fill in these 2 columns, whether it attracted or not. And once again, you can just tick the box if it attracted. If it didn't, put a cross. Okay, let's go. Whoops, before we go, you better write your aim in, and I'd like you to date it the day that you actually watched this video clip and completed the prac report. So remember, with aims, you start it with either to observe, to investigate, or to compare. So something that you could, an example for this one might be to investigate which materials are attracted to a magnet. So here's a magnet, first object, pencil, make sure you predict. Is it going to attract or not? Tick or cross. Attract, yes. Not attract, put a cross. All right, here's the pencil. Not really attracting. Nothing there. What is a pencil made out of? Never think about that. Next one, plastic straw. Make your prediction. Attract or not? Not really doing anything there either. The 2-cent piece. Who has never seen a 2-cent piece before? What's that animal? Okay, so here's my 2-cent piece. I hope you made your prediction. Write down your observation. an iron nail. What do we think? Make sure you make your prediction. I reckon you could safely say that that one attracted pretty strongly too. Look, I can pick it up. Stainless steel spatula. So this is the spatula that you guys use when we do experiments. Oh. What do you reckon, guys? What do you reckon on that one? Aluminium foil. Is it going to predict or not? I mean, is it going to attract or not? Make your prediction. Oh. Look at that. It just falls down. Why does it fall down? Why doesn't it just float off into space? Paperclip. Oh, let's have a look. Oh. Don't know if that'll be strong enough to... Oh, there we go. It's lifted the magnet. A little old paperclip. And now we have copper wire. So make sure you make your prediction. Copper wire. Now you'll find that in the wiring in your house. You know, that's up in the ceiling, that works your lights and your oven and your fridge. It's copper wiring. Now, is copper wiring going to be attracted? Have a think. Those guys that actually did the mixture that had iron and copper in it, you could probably predict this one pretty well. Oh. No attraction. Look at that. Try and pick it up. Nope. Now, there is a final row in that table. See that underneath copper wire? Now, if you've got a magnet at home, why don't you choose something from your home? It could be something from the kitchen, something from your pencil case. Ask your folks first, just to make sure that you're allowed to test it with a magnet. Do not, and please listen very carefully, do not try and test TV, laptop, phone, anything like that, computer. Don't, because you'll mess up the screen. So bank cards, don't put a magnet near a bank card, guys. You're really going to mess it up, okay? So just ask permission before you want to go test that object. So if you've got a magnet at home, feel free to even test some of the others that I've got there, you know, like a pencil, plastic straw, iron nail. You can do other coins, you know, maybe try out a 50-cent coin, a dollar coin, something like that. You can try your own spoons, you know, in your drawer. So have a bit of fun with that. Now, what you'll need to do is you'll need to answer those questions on the sheet. I'm just asking you to do it on the sheet. So therefore it makes it really easy just to take one photo and submit it on Zuno. And then, yep, don't forget, we always need to finish off with a conclusion. All right? Remember, a good way to start a conclusion was, it was found. You could also remember, don't personalise it, and include some of your results. So actually talk about some of the materials, you know, maybe that were attracted or that weren't attracted. What did those materials have in common that were attracted? Okay, thanks for watching, guys. Thank you to Professor Bones for helping me out. Have a great day, guys. All the best. Bye.